In continuation to first video, now I'm going to discuss basics of SAS. So first, the size of SAS dataset. Now the SAS version 9.4 is going on. Prior to 9.1 versions, you can create almost 32,767 columns or variables. But now in the 9.4 version, you can create as many as possible as per your CPU capacity. Sometimes in dataset you're going to miss the data. For example, if you don't receive the information from the subject, then that observation should be vacant, right? So now if any numeric data is missed, then it is represented by a dot, which we call it as a period in SAS language. And if character data is missed, it is represented by a blank. It remains vacant. And I have already discussed what is a numeric data and character data in my previous class. This is an example of data step. You can see here, to write the data step, you need to understand these following things which were highlighted in bold black color. So each data step should start with a data statement. So followed by, you have to give the output dataset name. So if you want to create a dataset, that whatever the name you want to give, that name you should write followed by the data statement. So after that, there is an infile statement. Infile means input file. Here we have written, after infile statement, we have written data lines. It's an indication that we are asking SAS to look into the data lines. Okay. Now input statement mainly focus on the variables. It includes the variables which we have to write to the SAS, in the SAS software. Followed by data lines. Data lines, we call it as a cards also. Okay, cards is another name for data lines. Both are synonymous with each other. So followed by, there is a data here. Okay, and we have to use a run statement. Okay, to end the data step with a semicolon. I have already told you every data step and proc step both should be end with a run statement followed by semicolon, right? So these are the important statements in the data step which you should remember. First thing is data, second is infile statement, third is input statement, and fourth is data lines and run statement. Okay, data step helps in creating data sets. Now if you open the SAS, there are libraries, okay, in the Explorer segment. So there are by default 6 libraries that are available in the SAS. So if you see that there is a work library, which is a a temporary library, you can say, because when you create a data set, every data set would be stored in the work library. But if you close the SAS session, data sets will be vanished, and it will remain empty whenever you open SAS again. So if you want to save your data sets in a permanent library, you have to create one permanent library. Okay, how we can create a permanent library? So if you see, this is the program that you have to write. First you have to write a libname statement, okay, and then you have to give a name to your library. Libref means lib reference. You have to give a library name, okay, that should not be more than 8 characters. Then after that, you have to give a path where you want to store that library and semicolon. Then if you submit this statement, then you can create a library. For example, I have created here Chiru library. You can see at the bottom of the statement, libname Chiru, and I have given a path where I want to store that library. Okay, now how data step is processed? You need to understand if you write a particular data step and how it is processed in the SAS. There are 2 steps in the process. One is compilation phase and second is execution phase. In compilation phase, each and every statement would be scrutinized. It would be checked for any syntax errors. Okay, if there is no error in your programming while writing a data step, then it will proceed to the next step. So at the end of compilation phase, SAS basically creates three things. One is input buffer, and second is program data vector, and third is descriptor portion. So you can see in input buffer, SAS will read the raw data into the input buffer. So initially the raw data would be read into the input buffer, and the program data vector, on the program data vector, this data set would be created. Okay, so if you see in the slide, that program data vector, initially the input file is read Okay, and all variables are created. After that, the PDV the data set would be created. SAS will read each observation at one time. Okay, at one time it will read only one observation, and after that again it will read it. After finishing the one observation, then again it will go to another observation and it will read another observation. This process is called iteration. If one observation is read and it is going to another observation, and then that process is called iteration. Okay, so in the descriptor portion, SAS will give the information about the dataset attributes and variable attributes. About attributes we will discuss in next class, but in addition to the variables which are present in the program data vector, there are few automatic variables that would be created by SAS itself. That is, one is underscore n underscore and underscore error underscore. If somebody asks you what are the automatic variables in PDV, that would be answer would be underscore n underscore and underscore error underscore. N indicates that number of observations. For example, if underscore n underscore equal to 2, that is the iteration it is second observation. And at the same time, if underscore error underscore equal to 0, then it's an indication that SAS program has no errors. Okay, so if it is 1, then it is indicating that errors are present in the program.